Hello Year 12. In this lesson we're going to look at protocols and standards, and we're going to go through your homework or your classwork that's been assigned for this week. And please note that this week our work is due in for Thursday at 3:20. The questions have already been posted in the classroom. So let's begin with this concept of standards and protocols. Like anything, when we talk about a standard, it's a benchmark. It's something that we try to aspire to. We can be above the standard, we can be below the standard. Just like we have a standard in Rathmore for academic success, some will be above, some will be below. So let's look at this with regards computing. So, well, to begin with, this is your homework questions. You've got 4 simple questions that again is due on Thursday, but in order to grasp these you need to look at the notes, which again has been posted in the classroom and has been attached to your notes. So the first thing that we're looking at is this concept of a standard. Again, I've mentioned that as a benchmark. It says in your notes here that they are guidelines, but historically they have been broken up into 2 types. We've got the legal standards, which are enforced by law. So lots across all industries there might be de jure standards. In computing, they might be legally enforced ones, like for example USB. That standard is encased in law. The same with other ones. I think HDMI for audiovisual, it's there written in law as a standard. Others are what we call by fact or by de facto. Just because of popular choice, they have become the norm. So a de facto standard might be, I'll sit down and listen to some MP3s, but I can listen to other audio formats. I'm thinking, though, that's supposed to be a paperclip. The paperclip symbol in an email is a de facto standard for attachment. You could write an application that uses a different icon. You know, it's not de jure, it's not the law. So there are the 2 types of standards, and then we come across protocols, and these are our rules, and that's what we're interested in this week. And I'm going to jump down, and the first rule that I'm going to look at is the IP. Now, IP is often bundled in with TCP/IP, but the purpose of it there, and I've just highlighted it, it is to do with addressing. Sorry, we're back online. So we're looking at addressing. IP uses 4 8-bit numbers to address a device or a network segment. And if you look at the example here, 255.255.255.255, these IP addresses can range between 0 and 255, hence the 8-bit format of it. They can be assigned statically. They can be pretty much hard-coded. A device or a router is given a static IP address. It doesn't change. Or it can be dynamically assigned by a protocol, Dynamic Host Control Protocol, where a server, a DHCP server, will allocate IP addresses as you jump onto the network. So for example, maybe your home hub that's using Wi-Fi, you can jump on with different devices and that router will allocate a series of IP addresses. Next we jump on to the second part of the lesson, is this concept of MAC addresses. And again, this is a protocol, it's a set of rules, it's enshrined, and the MAC control is used to uniquely identify devices. Every device that connects to a network has got a network interface card, as we already know. And on this network interface card, you will find a MAC address. And you can see here the MAC address is made up of 6 octets. 3 of those octets, or pairs of hex digits, are to do with the manufacturer. So for example, up here it says 01-4F21. They're hexadecimal values, and 3 of them are used to identify the device. And that allows IP addressing can identify individual segments on a network. MAC addresses will look at individual devices. When we combine this with TCP/IP, you're really just looking at a network stack, a stack of rules. TCP is concerned with format of the data packet. it assembles the data in a format that's able to be sent over a network. So in the simple diagram, I might have the data, the payload, and I might have a header, and TCP governs what will go into that header. The sender's IP, the receiver's IP, the sender's MAC, the receiver's MAC, the sequence identifier if there's a new number of packets, the error checking method, etc. And then on top of that, the IP, as we said, looks after the addressing. So what you have is the 4 questions. They're due in tomorrow. And again, as normal, if you've any questions, you can post to the stream and either someone in the class or I'll get back to you. Good luck, and don't forget, we meet again next Monday as normal.